Hmm. Good morning. Good morning or good evening? Good evening. So today we are going to learn physics half an hour and sometime maths also. We brought the quiz rubric quiz. Right? తీసుకురా. Huh? అవును అది చెయ్యి. ఏదైనా ఒకటే కదా. So this is a cube of 3 by 3. Okay. So now we have our student. Let me see how much fast he is going to do. Are you ready? Okay. Hello. So this is a cube to increase your thinking. This is a very good activity. Instead of seeing reels and everything, whenever you have time, I'm telling the students. So this is one of the important thing. So how much time you can do? How much time? 2 minutes. 3 minutes. Go there and in front of the camera. Come here. కెమెరా ముందర పెట్టి తీసుకో. ఇక్కడ రా. ఆ కెమెరా ముందర పెట్టి ఆ లైన్ ఫ్యాన్ వచ్చేసి కొద్దిగా పక్కకి. So it's one of the very important, very interesting activity. Um, it's a 3 by 3 cube. So time, in how much time it is going to be set, that is very important. If you take 1 hour, 2 hours time, easily anybody can do it. But कम टाइम में ये सब करना है. Okay. So everything comes under time. So it has no logic. It is just it depends on how your brain thinks. There are some methods to do it fast, but I believe everybody is thinking plays a very vital role. Some students will do it in 12 seconds, 15 seconds. If one color comes in the same, other colors will disturb. So it's very difficult. All the six surfaces, six or eight, how many surfaces? It's done. So it's almost done, completely done in 1 minute, I think. Within 1 minute, he has completed. So well done. So this type of cubes, whenever you are having free, okay, this is definitely this will increase your thinking, right? Your thinking power will increase. So buy one and keep it with you. Whenever you are having time, you can do it. Now today, I am going to continue this chapter. Gravitation chapter. So let me start my presentation. So in this lesson, fluid, let us understand what are fluids. Take a book and write down the definitions. Okay. So fluid is something, any substance which can flow are called fluids. Any substance which can flow are known as fluids. Okay. So very important characteristic of fluids, they exert pressure. Fluids exert pressure. So liquids and gases are also, we call it as fluids. Okay. Gas also will flow from one place to another place. So the important characteristic property of these fluids, they exert pressure. So let us understand little more about this concept. So now here you just see cyclones, the gases in the atmosphere, they exert pressure, right? And water, the liquid exert pressure, right? Let us understand the characteristic properties of pressure exerted by the fluids. Characteristics. In short, I has got no problem. Characteristic properties of pressure, which is exerted by the fluids. Okay. So every fluid, whether it is a water or whatever, every fluid exert pressure. Where it will exert? It will fluids exert pressure on the walls and the base. నువ్వు ఎలా రాసుకోవాలంటే ఆన్ exert pressure on walls and base of the container. Fluid need container, even the gas also need a container or a balloon or something. Okay. So then what happened? That fluid exert pressure on the walls and the base of the container. For example, this is the container, some fluid is there, blue color is there, don't think that it is water. Okay. So some fluid, so it exert pressure on the walls as well as the base of the container. In the same way, pressure exerted by the fluid is transmitted and undiminished in all the directions. So it will go in all the directions without being reduced. So for example, this is balloon. In this balloon, fluid will be there. That fluid is nothing but the gas. Even the gas in the balloon also exert pressure on the walls of the balloon. Okay, these are the very important characteristic properties of the pressure which is exerted by the fluid. So now let us see liquid pressure. Liquid pressure, gaseous pressure. First let us understand what is liquid pressure. pressure exerted by the liquids due to the weight of the liquid. Every fluid, uh, it will exert the pressure because of its weight. Okay, so liquids have weight, therefore they exert pressure as per the weight, as per their weights. Now, at a given depth of pressure, at a given depth, the pressure remains the same. Now, this is a flask, a container. Let us make three holes A, B, C at the same depth. Height should be the same. So, all the three holes are at the same height. So, then put the water inside. What happened? Both hole, from all the three holes, water will flow in the same pressure. Okay, so it gives that at a given depth the pressure remains the same. So in the examination he may be asked, it may be asked like this: prove that pressure at a given depth remains same. How are you going to prove? You have to write this experiment. Take a beaker, or take a water mug, or take a water jar, make holes at the three different. You draw the diagram like this and show it. Let us go to the fluid pressure through all the holes is same. Let us see, it depends on the height or depth of the liquid also. It's not only given depth, so it depends on the height or depth of the liquid, how much so now let us see, make three holes A, B, C at three different heights. A ऊपर करना है, B middle, C down. Okay, so different heights. In the first case, all the three holes at the same height. So here at three different heights. So then what happened? How the water will come? Which one has a low pressure? At A, it has a low pressure. At C, it has a high pressure. With lot of pressure, it is coming. Okay. So then the pressure of the liquid depends on the height, right? So different at different heights. Third case, what is the third case? It is independent of the size and shape of the container. Whatever the size, whatever the shape. Okay. Abhi, this is little bigger, right? Different shape. Even then, same thing. You make three holes at different shape and it is the same. Okay, irrespective. That is why the pressure is independent of the shape and size of the container. So these are the characteristic properties of the pressure exerted by the liquid. Now, difference between solid pressure and liquid pressure. Solid pressure and solid pressure kuda undi. What is the difference between solid pressure and liquid pressure? Now these are the books, solids, right? They exert pressure on the surface due to its weight. All these books they exert pressure on the table or wherever you keep. Okay, wherever you keep. So solids, all solids, here it is given books, every solid exert pressure on the surface where it is kept due to its weight. Okay, so liquid, the pressure is in this direction. Gas, let us understand, these are the fluids and these two, this is a solid. Okay, so fluids have weight, solid has having weight, solid exert pressure, fluid also exert pressure. So but in fluids, liquid and gases, fluids, they exert pressure in the container which they are enclosed, right? A fluid exert pressure in all the directions, but whereas the solid exert pressure in which direction? Only one direction. Which direction? Downwards, perpendicular to the ground, the direction of the so here, but whereas fluids they exert pressure in all the directions, you can see, in all the directions. whereas solid it exert in the perpendicular direction. Okay. Now let us understand little more about the fluids, buoyant force and laws of flotation and factors affecting buoyant force. So a doll in the liquid water, it is floating on the water. Why this floating happens, right? So let us have an experiment. Take a beaker, water in it, take a nail. When the nail is dropped in the water, what happens? It sinks. It sinks. It will float. It will not float. It will sink. Okay, you just see, and it will come to the base. So it sinks in the water. Now take a very big ship, but it is floating in the water. The ship is made up of metals. Okay, only one small make it is sinking in the water, but it has so many nails, right, made up of tons of irons, but it is floating on the water. Whereas a single nail is sinking, but here tons of iron, it's floating on the water. How it is possible? How it is possible? So let us see. A boat came, huh? A boat came, and boat is exerting pressure because it is a solid. It is exerting pressure downwards. Okay, boat exert a force on the water which is equal to the weight. ఎంత వెయిట్ ఉందో ఆ వెయిట్ అంతా కిందకి ఎగ్జర్ట్ చేస్తుంది, వెయిట్ ఆఫ్ ద బోట్ ఇట్ విల్ కమ్ డౌన్. అండ్ అట్ ద సేమ్ టైమ్ వన్ ఫోర్స్ ఈజ్ యాక్టింగ్ ఆపోజిట్ టు దిస్, అప్వర్డ్స్. ఇది perpendicularly డౌన్, ఇది perpendicularly upwards, and reaction of the force on the water, this exert upward force on the boat, right? So this upward force is known as buoyant force or upthrust. We have already learned. Okay, thrust and upthrust. So this force which is acting against the weight of the boat is known as buoyant force. It is also known as upthrust. Upthrust and buoyant force both are equal. Okay. So the upward definition, the upward force acting on a body immersed in a fluid is called upthrust or force of buoyancy. This buoyancy is nothing but a force, and the phenomenon is known as a buoyancy, and the force is buoyant force. Okay, buoyant force and buoyancy. Buoyancy is the phenomenon principle. Okay. In the ship, buoyant force is equal to the weight of the body. Therefore, the ship floats. Whatever is floating, whatever is floating in the body, in the fluid, even if you are swimming, you will be floating. Okay, because the force, buoyant, because of the buoyant force, you will float. Nail. The iron nail buoyant force is less than the weight of the body. Hence, the nail sinks. Whatever the force is acting opposite to this. Every object, ప్రతి ఆబ్జెక్ట్కి ఫ్లూయిడ్లో పడితే buoyant force యాక్ట్ అవుతుంది. కానీ నెయిల్కి ఏమవుతుంది? buoyant force is very less than the weight of the force. Therefore, it will sink in the water. Okay. Now let us take one more example. There are it depends, buoyant force depends on the density also, right? It depends on the density. There are three. First you should know what is density. What is density? BF means buoyant force. ఇక్కడ ఫస్ట్ దానికి greater than weight. When buoyant force is greater than the weight of the body, it will float on the water. When the density of the water is greater than that body, then the body floats on the water. When the buoyant force is equal to the weight, then it is partially floats on the water. So in the second case, buoyant force is equal to the weight. Can you tell me the third one? Less than the weight. Okay, buoyant force is less than the weight of the body, therefore it sinks. It sinks in the, so loss of flotation. These are the laws of flotation. A body will float in the liquid if the density is less than the density of the body is less than the density of the liquid. If the density of the body is less than the density of the liquid. I am talking about here liquid. Liquid can be water, liquid can be anything. Okay. So then a body will be floating. This is first law. Second law, if the body will be in the equilibrium at any submerged depth, if the density of the body is equal to the density of the liquid. దీనికి ఎగ్జాంపుల్ చెప్పగలవా? What is the example for the second? ఐస్ ఏమో, ఐస్ కూడా అయిండొచ్చు కదా, డెన్సిటీ కదా. హియర్ డెన్సిటీస్ కదా, density of ice, density of water, both are same. So it will be like this. Okay. Third law, the body will sink in the liquid if the density is greater than the density of the liquid. These are the laws of flotation. Okay. So buoyant force is directly proportional to volume of the object and volume of the object. So it has a very less volume, it has a more volume. So more volume, more buoyant force. Less volume, less buoyant force. So that is why it made a bigger volume. Nail has a very less volume, therefore it is a buoyant force is very less, therefore it sinks. So buoyant force ni ekku cheyali ante, if you want to increase the buoyant force, you have to increase the more volume. ఎంత ఎక్కువ వాల్యూమ్ ఉంటే అంత buoyant force పెరుగుతుంది. So then body will float in the fluid or water. Okay. So density of the liquid, it also directly proportional to the density of the liquid, depends on the weight of the liquid displaced. See here, it depends on the weight of the liquid, is how much liquid is displaced by him, even that matters, right? Swimming in the sea water is easy as the density of water is very high. Huh? River water is difficult because the density of water is very low. River లో స్విమ్ చేయడం చాలా కష్టం. రెండు it looks like water only, but it is different. Sea water లో ఈజీగా చేయాలి. Sea water ఈజీ, రైట్, ఎందుకంటే వాటర్ సాల్ట్ ఎక్కువ ఉంటుంది కదా, సో డెన్సిటీ హై ఉంటుంది కాబట్టి ఇక్కడ ఈజీగా ఫ్లోట్ అవ్వచ్చు, రైట్. రివర్ ఇట్స్ డిఫికల్ట్, మన కాలువ కూడా డిఫికల్టే బికాస్ ఆల్ ద కెనాల్ వాటర్ ఈస్ ఫ్రమ్ ద గోదావరి ఓన్లీ. సో Archimedes principle comes on this only. Archimedes principle. What is Archimedes principle? Is Archimedes Swamiji, right? When a body is immersed, ఇది తెలుసా, ఇది పాటికి మీరు చిన్నప్పుడే నేర్చుకోవాలి ఇది. When a body is immersed completely or partially in the fluid, మొత్తం అయినా సరే పార్షియల్గా అయినా సరే మునిగితే కానీ అప్పుడు ఏమవుతుంది, ఇట్ ఎక్స్పీరియన్సెస్ అండ్ అప్వర్డ్ ఫోర్స్ థ్రస్ట్ వస్తుంది కదా పైకి, బయోయిన్ ఫోర్స్, అండ్ దట్ ఈజ్ ఈక్వల్ టు వెయిట్ ఆఫ్ ద ఫ్లూయిడ్ డిస్ప్లేస్డ్ బై ఇట్. ఎంత ఆ బాడీ ఎంత వాటర్ని డిస్ప్లేస్ చేస్తుంది అన్నది ఇట్ డిపెండ్స్ అనమాట. సో దిస్ ఈజ్ ఆర్కిమెడిస్ ప్రిన్సిపల్. Take a solid, a metallic piece, okay, solid, suspend it in the hook, spring balance, right, and note its weight. Weight ఎంత ఉంటుంది, 300 ఉంది ఇక్కడ, W1 అనుకోవాలి ఇక్కడ, ఇది 300, 500, whatever, W1 అనుకోవాలి, అంటే వెయిట్ ఆఫ్ ద వాటర్ ఇన్ ద ఎయిర్ అనమాట, 500, రైట్. సో నౌ టేక్ ఏ యురేకా అండ్ కెన్ ఫిల్ ద వాటర్. దీన్ని వాటర్తో ఫిల్ చేసేసేయండి, అంతే, ఏదో వచ్చాడంతే. ఇది ఇలాంటి దాన్ని యురేకా అంటారు. సో ఎందుకంటే మరి ఇది ఇవ్వగానే ఏమవుతుంది, కొంత వాటర్ బయటకు రావాలి కదా, ఇలాంటి ఒక జార్ తీసుకోవాలి. అప్పుడు దెన్ ఇక్కడ ఆల్రెడీ ఇది ఇన్ ద ఎయిర్ 500, దీన్ని స్ప్రింగ్ బ్యాలెన్స్ని స్లోగా కిందకి తీసుకోండి. ఇది స్పౌట్, ఇది యురేకా క్యాన్ అంటాం. దిస్ క్యాన్ ఈజ్ కాల్డ్ యురేకా క్యాన్. సో దెన్ ఇది ఇక్కడ నుంచి ఎప్పుడైతే ఈ సాలిడ్ దీంట్లోకి వస్తుందో కొంత వాటర్ పైకి వస్తుంది కదా, ఆ పైకి వచ్చిన వాటర్ దీనిలోంచి ఇట్ విల్ కమ్ ఇన్ టు దిస్. ఇది మెజరింగ్ సిలిండర్ అనమాట. సో దెన్ డ్రాప్ ఇట్. Then what happened? Some water will come and the water displaced by this solid will come into this. So ఇక్కడ ఎంత వాటర్ వచ్చిందో వస్తుంది కదా, అమౌంట్ ఆఫ్ వాటర్ డిస్ప్లేస్డ్ బై ద బాడీ, దిస్ వన్. సో దిస్ ఈస్ ద అమౌంట్ ఆఫ్ ద వాటర్ డిస్ప్లేస్డ్ బై ద సాలిడ్, 100 grams ఫర్ ఎగ్జాంపుల్. సో ఇక్కడ వెయిట్ ఆల్రెడీ పెరిగింది చూసారా, వెయిట్ తగ్గింది. ఇందాక 500 ఉండేది, ఇప్పుడు 400 అయింది. ఇది 400 అంటే W2 అనమాట, 400. సో ఎంత డిఫరెన్స్ వచ్చింది, 100 వచ్చింది. ఆ 100 ఇక్కడికి వచ్చేస్తుంది అనమాట. So apparent loss of the liquid is 500 minus 400 into 9 point. What is this 9.8? The acceleration due to gravity. W is equal to mg kada, F is equal to ma. E ante acceleration. If F is the force weight, then it was ma badalu mg avutundi. So it is 980 newtons. Okay. So this is the experiment to demonstrate Archimedes principle. Weight of the water displaced, mg is equal to 100, 980. So both are equal, 980, 980. Both are equal. Thus apparent loss of the weight is equal to apparent of weight of water displaced. Avana? So we will stop here. చేసేద్దాం. అవును, మ్యాథ్స్ చేయాలి కదా, we have to do math. We will complete this Archimedes principle. Designing ships, submarines, all these things, the main principle is Archimedes principle only. This is, what is this called? Submarine. Okay. Various instruments like lactometer, hydrometer. Chesna రావులపాలెంలో లాక్టోమీటర్ తెలియాలి. పాలల్లో ఎన్ని నీళ్ళు కలిసి ఉన్నాయో ఎలా తెలుస్తుంది? తెలుస్తుంది వాడితే మరి. ఊళ్ళో ఉన్నారు బయట. ప్యూరిటీ ఆఫ్ ద మిల్క్, ఎన్ని నీళ్ళు కలిపారు, ఎంత ప్యూర్గా ఉన్నది, లాక్టోమీటర్ ఈజ్ యూస్డ్. హైడ్రోమీటర్ అంటే it is used to find the density of the water, density of the liquid in with respect to the water. So both are measured on the Archimedes principle. So density, already you will be knowing what is density. Density is nothing but mass per unit volume. Mass to its volume. Mass by volume. Density is equal to mass by volume. What is the unit? Mass की unit ఏంది kilograms. Volume की liter. Okay. SI unit kilogram meter cube, kilogram centimeter cube. Relative density, it is also known as specific gravity. Specific gravity anna relative density anna okate, both are same. So what is relative density? Density of the substance by density of the water. అంటే ఏదో ఒక డెన్సిటీ ఆఫ్ ద సబ్స్టెన్స్ తీసుకుని దాని డెన్సిటీ ఆఫ్ ద వాటర్తో తీసుకుంటే దెన్ యూ విల్ బి గెటింగ్ ద రిలేటివ్ డెన్సిటీ. దిస్ ఈజ్ ఆల్సో నోన్ ఎస్ స్పెసిఫిక్ గ్రావిటీ. Specific gravity of a substance. So density of the substance divided by density of water, we will get a relative density. So what is the form? What is the unit? These two will get cancelled. So it has no unit because it is similar. Whatever the density, it is constant. Relative density of a particular substance is always constant. Okay. So it has no unit. That's it. ఇది ఇంకా ప్రాబ్లమ్స్ ఫార్ములా రాసుకుంటావా? ఓకే. Let us stop it. So this is all for today physics. Let us go to maths. Okay. So we have to do the questions na. Textbook ఇలా ఇచ్చేసి. The final exercise of quadrilaterals. నిన్న థియరమ్స్ చేసేసాం కదా, 8.2 థియరమ్స్ చేయాలి. So yesterday in yesterday's class I have explained you the midpoint theorem. Let me explain it again. So a triangle PQR. So now there is a midpoint of this PQ and midpoint of PR. Let us say A and B. So if you join this A and B, what happened? AB is the line joining the midpoints. Okay. So then AB is parallel to BC, sorry, QR. This is first result. And the second result is AB is equal to half of QR. So based on this, you have some, suppose if it is 4 centimeters, how much is this? 8. Suppose if it is 3 centimeters, how much is this? 3 only. A is the midpoint kada. Suppose if it is 3.5, then how much is this? 3.5. Okay. Suppose in the place of BC 8, if I write 7, then how much is this? 3.5. So such questions will come. Midpoint theorem. Very, very important. Huh? 1 mark questions. So the line joining the midpoint is parallel to QR and equal to half of QR. Samjhe? So you should be able to apply midpoint theorem very happily in every situation. Let us apply situation in a quadrilateral. In a quadrilateral. Okay. Let me draw a quadrilateral. I am not teaching any question. It is not a parallelogram. It is not a rectangle. It is a quadrilateral. It is not rhombus. It is not trapezium. Okay. So now let us take the midpoints of all the sides. AB midpoint is P. BC midpoint is Q. And CD midpoint is, let us say, R. And AD midpoint is S. Now if I join this, it is a line joining the midpoints of two sides. Now what I will do, I will join the diagonal. I will join the diagonal. So then what happened? You have a triangle ABC. Am I right? ABC and AD. ABC. In this, PQ is line joining the midpoints. Am I right? Therefore, PQ is parallel to dash. PQ is equal to dash.
PQ parallel to SR.
Huh?
PQ parallel to SR.
AC. This is third side kada.
Half of the
You have to take the triangle. You should take the triangle. This is the triangle you have to take. So PQ is the line joining the PQ is the line joining the midpoints. This line joining the midpoints, you should take only the triangle. So PQ is equal to how much? Parallel to AC, and PQ is equal to half of AC. Am I right? At the same time, you work on the other triangle also. Okay. Now let me join this. Got it? So then SR. SR is the line joining the midpoints. Am I right? Midpoints of AD and DC. Now in triangle ADC, that green color wala ADC. So then what happened? SR is parallel to what? AC. Very good. And SR is equal to what? 1 by 2 AC. Now you understand these two. Observe these two. Right hand sides are equal. Right hand sides equal na? AC. Here AC. Okay. And half AC, half AC. Therefore, what happens? SR is parallel to PQ and SR is equal to PQ. First condition parallel ఉంది కాబట్టి you have to write the parallel symbol. Second condition equal to is there, so you should write equal to. And you understood? So now I will join. What I will join? I will join SP and I will join RQ. You are getting a parallelogram, sorry, a quadrilateral inside PQRS. PQRS is a quadrilateral. You got it? If you join, no, if you join, it is a quadrilateral first. Now in this quadrilateral, this has come. That means one pair one pair is parallel and equal. PQ is parallel to SR and PQ is equal to SR. Therefore, PQRS is a parallelogram. Got it? Parallelogram ఎప్పుడు అవుతుంది? If one pair of opposite sides are parallel and equal అయితే కనుక ఆ PQRS ఆ కోరిలేటరల్ ఏదైతే ఉందో అది parallelogram అవుతుంది. సో ఇదే క్వశ్చన్ అక్కడ మనకి ఫస్ట్ క్వశ్చన్ ఉంది. దిస్ ఈజ్ నథింగ్ బట్ ద క్వశ్చన్ నెంబర్ 1. సో సేమ్ కాన్సెప్ట్ యూ హ్యావ్ టు అప్లై ఆల్మోస్ట్ ఇన్ ఎవ్రీ ప్రాబ్లమ్. ఎవ్రీ క్వార్టర్లేటర్లో ఇలాగే అప్లై చేసుకోవచ్చు. ఇప్పుడు నేను ఐ హ్యావ్ అప్లైడ్ దిస్ కాన్సెప్ట్ ఇన్ ద క్వార్టర్లేటరల్. You can apply it in parallelogram, you can apply it in rectangle, you can apply it in rhombus. You draw a rhombus, you draw a square, you draw a rectangle, okay, and you can mark the midpoints of all the four sides, join, like make a form a quadrilateral. Identify what type of quadrilateral is that. What type of quadrilateral is that? Only one is there in the in live class. One is me, one is somebody. Tarun, are you there? Tarun must be open and doing his work. Okay. So this is a first question, right? PQRS is a parallelogram. Got it? Now let us go to another question. So how this question will be given, I will just give you. We have done it now, right? How the question comes. The quadrilateral, I am writing quadrilateral. Last one. Quadrilateral formed by joining the midpoints of consecutive sides of a quadrilateral is a parallelogram. అర్థమైందా? Quadrilateral formed by the joining the midpoints of consecutive sides of a quadrilateral is a parallelogram. I did not share it in the group today. Yesterday I shared. Huh? 17 వస్తున్నారు పోతున్నారు కదా మధ్యలో. వేసేనే క్లాస్ 9లో వచ్చింది ఇక్కడ. ఉంది కానీ నేను దాంట్లో ఎవరు పెట్టడానికి ఉండదు కదా. No, no, no. ఓకే, సో ఇక్కడ చూడండి, ఇక్కడ ద క్వాడ్రిలేటరల్ ఫార్మ్డ్ ఇది ఒకటి, బై జాయినింగ్ ద మిడ్ పాయింట్స్ ఆఫ్ కన్సిక్యూటివ్ సైడ్స్ ఆఫ్ క్వాడ్రిలేటరల్ ఈజ్ ప్యారలలోగ్రామ్. ఈ మూడు. సో దీన్ని, ఈ ఫస్ట్ దాన్ని యూ కెన్ హ్యావ్ క్వాడ్రిలేటరల్ ఓన్లీ, నో చేంజ్. సెకండ్ది, దీన్ని మనం ఏం చేసుకోవచ్చు, ఒకసారి ప్యారలలోగ్రామ్ చేద్దాం. ప్యారలలోగ్రామ్ అప్పుడు ఇది ఏమవుతుంది అని చేయాలి. అంటే క్వాడ్రిలేటరల్ ఫార్మ్డ్ బై ద జాయినింగ్ ద మిడ్ పాయింట్స్ ఆఫ్ కన్సిక్యూటివ్ సైడ్స్ ఆఫ్ ఏ ప్యారలలోగ్రామ్ ఈజ్ డాష్. समझे? Let us do na. I am going to draw parallelogram. I have to draw a parallelogram kada. Quadrilaterals midpoint రావాలి కదా మనకి. First you have to draw the parallelogram. Okay. First we have to draw the parallelogram. So this is ABCD is the parallelogram. And midpoints of these sides. These are the midpoints of these sides. Let us say PQRS. D kada PQRS. So the quadrilateral formed by the joining the consecutive midpoints. This is consecutive midpoints. This is consecutive midpoints. And this is consecutive midpoints. And this is consecutive midpoint. Now we have got a quadrilateral. So this quadrilateral is PQRS. And this quadrilateral I wrote parallelogram na. This is ABCD. Now what happened to this PQRS? Definitely it is a parallelogram. Okay. So ఇది parallelogram. PQRS is a parallelogram. ఇందాక ప్రూవ్ చేసాం కదా, ఇది parallelogram. Definitely it is a parallelogram like previous proof. Then what else other than parallelogram? Other than parallelogram. So అది ప్రూవ్ చేయాలి. You take a diagonal. Got it? Diagonal. So then in the it is a parallelogram kada. You take one more diagonal. Shall we take one more diagonal? Let us see. Right? What properties you will be getting. So in the not diagonals, let us remove this diagonal also. Let us join the diagonals of PQRS. PR. And this PR is equal to how much? PR is equal to AD. Am I right? Which is equal to BC. ఎందుకంటే బీసీ ఏడి ఈక్వల్ కదా, ఆపోజిట్ సైడ్స్ ఆర్ ఈక్వల్, ఈ రెండు సైడ్స్ ఈక్వల్ కదా. సో ఇది లైన్ జాయినింగ్ ది మిడ్ పాయింట్ కాబట్టి ఇది కూడా ఈ రెండింటికి ఈక్వల్ అవుతుంది. దేర్ ఫోర్ పిఆర్ ఈజ్ ఈక్వల్ టు ఏడి ఈజ్ ఈక్వల్ టు బీసీ. ఓకే, ఇది నెంబర్ 1. లెట్ మీ చేంజ్ ద కలర్. ఓకే, సేమ్ వే. SQ is equal to CD. ఇది సెకండ్. ఓకే, సో ఆర్ దే ఈక్వల్? ఆర్ దే ఈక్వల్? మిడ్ పాయింట్ ఓ పెట్టుకోండి, మిడ్ పాయింట్ ఓ పెట్టుకోవచ్చు. Okay, so if these diagonals are equal, then it is a rectangle. So are they equal? We don't know. It is just a parallelogram kada. So it will be a rectangle, it might be a rectangle. Rectangle లో ఇవి ఈక్వల్ ఉండాలి కదా మరి. సో ఇట్ ఈస్ ఏ parallelogram, it is a parallelogram. ఓకే, ఈ parallelogram రెక్టాంగిల్ అవ్వాలంటే డయాగ్నల్స్ ఈక్వల్ అవ్వచ్చు, లేకపోతే వన్ యాంగిల్ 90 degrees అవ్వచ్చు. ఓకే, స్క్వేర్ అవ్వాలంటే డయాగ్నల్స్ ఈక్వల్ ఉండాలి, సైడ్స్ ఈక్వల్ ఉండాలి. రాంబస్ అవ్వాలంటే ఆ రెండు డయాగ్నల్స్ పెర్పెండిక్యులర్ అవ్వాలి. చూస్తే కాదు, మనకి రూల్ అయ్యాలి. ఎందుకంటే ఆ ప్యారలోగ్రామ్ రాంబస్లో చేసింది కదా. ఆ ప్యారలోగ్రామ్ ఈస్ లుకింగ్ లైక్ రాంబస్, ఆల్ ద సైడ్స్ ఆర్ ఈక్వల్. సో డయాగ్నల్స్ ఈక్వల్ కాదే, diagonals are not equal. Diagonals, when it is equal, if AD and AB are equal, ఇవి ఈక్వల్ అయితేనే డయాగ్నల్స్ ఈక్వల్ అవుతాయి. ఈ రెండు ఈక్వల్ అయితేనే డయాగ్నల్స్ ఈక్వల్ అవుతాయి, లేదా అవ్వు. సో ఈ రెండు ఈక్వల్ అవునా కదా మనకి తెలియదు కదా. ఏడి ఏబి ఈక్వల్ అవునా కదా తెలియదు. ఈక్వల్ ఎప్పుడు అవుతాయి? ఇది రాంబస్లో ఈక్వల్ అవుతాయి. సో ఇది రాంబస్ అయింది అనుకో, ప్యారలలోగ్రామ్ బదులు రాంబస్ అయితే కనుక అప్పుడు ఈ డయాగ్నల్స్ ఈక్వల్ అవుతాయి, అప్పుడు ఇది రెక్టాంగిల్ అవుతుంది. సమझे? సో దిస్ ఈజ్ హౌ యూ హ్యావ్ టు డూ దీస్ క్వశ్చన్స్. అన్ని క్వశ్చన్స్ సేమ్ మోడల్. ఓకే, స్టాటిస్టిక్స్కి వెళ్దాం, లేకపోతే ఇది చేద్దాం. చెప్పేసాను కదా, సర్కిల్స్కి వెళ్దాం. ఈ క్వశ్చన్స్ అన్నీ ఒకటే మోడల్ మొత్తం. ఆల్ ద 6 questions, there are only 6 questions, all the 6 questions are of the same model. Okay.